Good afternoon, class.
Good afternoon, sir.
Sorry for the delay in start. It's fine, okay. Talking for everybody. Everybody else want to learn, you say it's fine. You don't want to learn. Right. So yesterday we spoke about the volume of a right prism, not so? And I gave you homework was exercise 8.1. Okay, so let's just do the volume calculations here quickly. So this is exercise 8.1 and this is on page 260. Exercise 2.1, page 260.
Laat het. Hoe laat?
4 o'clock.
4 o'clock. 4 o'clock is too.
Oh, okay. So you're leaving before me today?
5 o'clock.
I'm going to be here till 4 o'clock.
Okay.
Right. So exercise 8.1, page 240. We are told to calculate the volume of the box of juice in the photograph. Write it as liquid volume. Okay, so to calculate the volume is going to be length times breadth times height. Not so. So it's going to be 9 times 5,8 times 19.5. So that's going to give us 9 times 5.8 times 19.5. That gives us an answer of 1017,9. 1017,9 centimeters cubed. Then the question says you must give it in terms what is the liquid volume. So I think they wanted in milliliters, no? So 1 centimeter cube is equal to 1 milliliter. That's very important to remember. So therefore the volume will be 1017,9 milliliters. So, or it could be 1,017 or 18 liters. Okay. Let's look at number 2. In number 2, we are told that the table gives some standard dimensions or circumferences of spherical balls in sports. Copy and paste. Copy and paste. Copy the table and fill in the missing measurements in centimeters correctly to decimal places. 1 inch is 2,5. People, any problems here? Yes?
For football.
Football. So that's the issue. So the standard circumference. So the standard diameter. So the circumference of the ball is, so looking at football in particular, is 27.5 inches. Okay? So the standard diameter is going to be from one end to the other. Not so? So how do you calculate circumference? It was 2 pi r. Not so? So you got 27.5 is equal to 2 pi, and the radius is what I'm calculating. So I divide both sides by 2 pi. So my radius works out to be 27.5 over 2 pi. Let me just change here quickly, sorry. So it's going to be 27.5 over 2 pi. That gives me 4,3 inches. 4.3 inches, but looking at the diameter, so it's double that. So I times that answer by 2. It's going to be 8,75. No, inches. Okay. But they want the answer in centimeters. Yes. Like, no problem. So we know that 1 inch, I don't know if there's nothing behind the calculator. Okay, not actually. So 1 inch is equal to 2.54 centimeters. Not so. So if there's 8,75 inches, so I'm doing it from 1 to 8,75, I multiply it by that. Not so. So we then say 2,54 times 8,75. So that answer will be your centimeter answer. So that answer multiplied by 2.54. That gives you 22,23. 22,23 or 22,2 centimeters. They wanted it millimeters, is 2 decimal places, no problem. They wanted it in millimeters, and then it gets times by 10, so it's 222,3 millimeters. What's the answer they have?
No, I'm up, sir.
Man.
Volume, sorry. The volume, sir.
The volume.
Yes, sir.
Is the answer in centimeters or in meters? In millimeters.
Centimeters.
Centimeters. So then I must use the radius in centimeters, okay? So I can take this off now. So the volume, how do you calculate the volume? Volume of a sphere? 4/3 power cubed, not so? So that's going to give you 4/3 pi. My radius is half of this. So it's going to be 22,23 divided by 2 cubed. And that gives us an answer of, so it's 4/3 pi times, open brackets, your diameter over 2 cubed. 5755, comma 04 centimeters cubed. Okay. So I'm wrong, you say?
No, so I got the same thing.
You got the same.
But then the book is
What's the answer in the book?
5,751.
5751. So that is just like
That's about
4 comma, that's 4 comma something centimeters, very little. Okay, let's see what they got, how they got it. I would say that they didn't use they might have not used the answer, but let's see. So let's see, they got 22.23. And there you go. I go lying.
It seemed like a lot.
It's little. But yeah, but you are right to ask. I feel better now that I got your answer. Now it feels like I'm on the right track. Right, any other problems here with any balls you're having problems with? On the board? No balls? Let's carry on with our lives. Why are you laughing? And that was coupled with those tables, no?
Yes, sir.
Then, number 3. Any issues with number 3? Does that do it? No. Number 4? Yes. Okay, let me just do number 3 as well. Maybe somebody that do their work in future would have wondered why we didn't do number 3. Okay. So a conical tent has a circular base with a diameter, so you have something looking like that there. It has a diameter of 3 meters. Okay? And the slanted height, or a cone. So a conical, sorry. I'm taking a tent. It's in the shape of a cylinder. So a conical, something like that it should look like. No? Has a circular base with a diameter of 3 meters. Okay? And a slanted height, so the perpendicular height is under, a slanted height of 3 meters. what is the volume? How do you calculate the volume of a cone? It's a third area of base times perpendicular height. So, I need to work out my perpendicular height here, not so? So if you're going to look at the perpendicular height here, your perpendicular height is going to be that thing, from there to there, it's going to be 1.5 and 3, not so? So your perpendicular height would be the square root of 3 squared minus 1.5 squared. So the square root of 3 squared minus 1.5 squared. That gives us 2,59. And the number of course carries on. No? So it will be a third area of base. How do you calculate the area of a circle? It's pi r, which is 1.5 squared, times 2.59, and the number of course carries on. So you have 1 over 3 pi times 1.5 squared times that answer. That's 6,12. 6,12 meters cube. Is that correct? Yes. You got a different answer, Michael?
No,
Huh?
it's I said centimeters.
Sit here. What kind of girl are you then? Imagine 6,12. You're going to get a tint like... I'm not going to sleep in so small. Okay, then number 4. What is it?
She said she could.
You'll fit in a... She will fit in a 6,12 centimeter cube.
Yeah.
Something small will go in there only here. The rest, I don't know where the rest of you are going to go. Okay.
Like Abby tried.
Okay. Okay, relax. It is fine. The rest rather to the sun. The next one. Number 4. What's the difference in volume? So we must work out the volumes and subtract it. Ne? What's the difference in volume of a pyramid with a square base? So a square base pyramid. I'm not the best at this drawing, okay? Square base pyramid, so all these lengths are the same. Okay? Besides 6, and a pyramid with an equilateral triangle. You both have a height of 8. What is the other one? A pyramid with equilateral triangles, side 6. Okay, triangle. Okay, I can't draw that thing. It's not right, no? Let's go equilateral triangle, side 6. Not so? Of course I can't draw this thing. But all these lengths are the same. So what type of shape is that? A tetrahedron, no? We spoke about that yesterday. Now the height of this is going to be also 8. Alright. So firstly, let's call this shape 1. This is the second shape. So the volume of the first shape is going to be a third area of base times perpendicular height. Not so? So it's going to be a third. How do you calculate the area of a square? Side square. So it's going to be 6 squared times the perpendicular height, which is 8. What's wrong, Michael? Yes?
So like for the area, would you have to like state the specific places, shape the formula of the specific? No.
So you want to say a third times side square times h?
Yeah.
No, you don't have to.
You don't have to.
No? But if you really want to and you believe that's how you're going to take over the world, then you can do it that way. But you don't have to. So that's a third times 6 squared times 8. It's going to give you 96 meters cubed. Now the volume of the second shape is going to be also a third area of base times perpendicular height. So you got the third times. Now what you have here is a what's the name, triangle, and an equilateral triangle. Not so. So if you look at that equilateral triangle, remember this is all 6 here. Okay. So I need to know. Remember, for the area of a triangle, so half a base times height, perpendicular height. So the perpendicular height of the base of that triangle, I need to calculate. Can you see that? So in other words, we got the triangle looking like this here, with that being 3, because half from there to there is half, and the perpendicular height is what I'm calculating, while the slanted height is the hypotenuse in this case, which is 6. You all agree with that? Let's call this rather capital H1 up, because otherwise you're going to have too many perpendicular heights in this calculation. Okay? So the perpendicular height here is going to be 6 squared minus 3 squared, the square root thereof. Okay? The square root of 6 squared minus 3 squared. It's 3 root 3. Okay, so it's going to be half base. What's the base of this triangle? 6. And the height we just calculated, which is 3 root 3, times the depth of this object, or the perpendicular height, which is 8. Okay. So we work this out. So it's a third times half times 6 times 3 root 3 times 8. That gives you 24 root 3 meters cubed.
Mr. Bodin?
Yes, miss?
You perhaps have Grace by is in your class.
Yes, miss?
She can come to the office with the bags, please.
Okay. So the difference, I have to take I have to subtract the 2, not so? So I think that the volume 1 is the bigger one, minus volume 2, so it's 96 minus 24 root 3. Or you could have changed that to its decimal equivalent already. So it's 96 minus that answer, gives us an answer of 54,43. And what's the answer there? Meters cubed. So that's the difference in those two shapes. Who's Grace? Okay. Go now straight to the office, no? You're not coming to this afternoon's lesson? Huh? Oh yes, you that girl. I remember now. Sorry man, I forget. Don't forget the homework is going to be 8 point, the next exercise, no? People, any problems with number 5? Any problems with number 5? No? Number 6? Yes. Okay. 6A. Just sort this out. Bye. We are told that what is the volume of the metal in a pipe with a hollow radius of 10 centimeters, an outer radius of 12 centimeters, and a length of, okay, so basically what you have here, you have a pipe like this, okay, and the pipe looks like that. Inside this pipe, you got this hollow section. Can you see that? So that's the scenario. Right? So again, what is the volume of the metal in the pipe? This part here, the volume of that. Okay? With a hollow radius, hollow means empty, no? Empty radius of 10, and an outer radius from center to the outer part, 12 centimeters. Okay? You guys understand? And a length of 20 centimeters. Right, so in other words, I must work out the volume. Right? Volume of the metal, yes?
Sir,
Just let go that way. Yes?
what's the inside and your
What is this?
I have no idea.
So much the same. I might say, paycheck away. The whole 100 rand I'm getting. You can come help us with the maths. Don't be happy. Is it today? Where else? Thank you. Next one. So let's call this the first one, the volume of the outer. Of course, the outer is going to be bigger, not so. So the volume of the outer cylinder is going to be, how do you calculate the area of a cylinder? It's area of base times height, not so. So area of a circle, pi r squared, so the volume is written pi r squared times the depth of the object. So it's going to be pi r, which was the outer circle, so it's 12 squared, times the depth, which is 20, minus pi times r, which is 10 squared times 20. Okay? So that's going to give us pi times 12 squared times 20 minus pi times 10 squared times 20. It's going to be 885, which is 2764,6 centimeters cubed. Is that correct?
Yes.
Okay. You know what's the volume of the hollow center? We didn't. This is the volume of the hollow center. Not so? Is this not the answer for A? So I don't understand why would they ask you that first? Because normally they would Normally they would ask you that first. Okay, but anyway, so the volume of the hollow center is going to be pi 10 squared times 20. It doesn't make sense to ask that after. What's the answer there?
That's right, so.
Crazy man, why would they? I don't understand. 2000 pi. So 6 to 8. 3.19 centimeters cubed. Okay? Yes?
So
Yes.
why can't you, because you're looking for the metal part.
Yes.
Why can't you say 12 minus 10 and then
They will give you a,
calculate from there?
because if you're going to calculate what you're talking about, then actually you got 2 centimeters there. Not so? Now from that center, 2 centimeters, you'll then create another small circle inside. That is why you won't be able to subtract that 10 and that 12 to get 2. Verstaan jy? Alright. That all. Right, now we're going to look at surface area. Which page are we on now? Example. Page 262. Okay, so here we are told the surface area of a 3D object means the total area of all the faces of the object. The tricky thing about finding the surface area is keeping track of all the surfaces. It helps to draw or to visualize the net of the 3D object. The only object you can do this, you cannot, and the only object you can't do this with is a sphere. Okay. The rest of it you can draw nets. Okay, now in grade 8 and 9, I'm sure you guys drew a lot of nets, no? Right? So if you that kind of girl who want to draw a net, no problem, you draw a net. Okay. The question says, determine the surface area of the following solids. All measurements are in centimeters and do the calculation correct to 1 decimal place. So let's look at the first shape here. So number 1. Again we have the square, the rectangular base right prism. No? So how do we calculate the surface area of a right prism? We always follow the formula. Perimeter of base times height plus 2 area of base. Okay. You all remember that, no? So how do you calculate the perimeter? Remember, that's your base. How do you calculate the perimeter of a rectangular base? 2 length plus 2 breadth. Not so? So this would be 2 times 5 plus 2 times 2. So that's the perimeter of the base. If I multiply by the height, I'm accounting for those 4 and the one facing us. The embodiment of that object. Can you see that, people? So the perimeter of the base times height, you're actually accounting for the body of this object. Okay? And the height is what? 8 plus. So that is sorted, no? Plus twice area of the base. What type of shape is this base again? Rectangular base. How do you calculate the area of a rectangle? It's length, and what's my length? 5 times the breadth, which is 2. Or 2 times 5. Okay? So from here we can work this out. What that from now? What did we get?
132.
132. You all okay with that? Centimeters. Now if you want to draw the net, no problem. You'll realize there are 3 different rectangles. Not so? And then you just work it out. You're going to say 5 times 2 times 2. So there's 2 of these with a net. Then you got the 2 by 8 times 2. Is that one and that one. And you got the 5 by 8 times 2, which is that face facing us, and the one on the other side. Okay, you can do it like that as well. Both ways you're going to get the full answer, the full mark. And you get an answer of 132. Okay, people, you guys understand? Any confusion here? Yeah, moving too fast? No, okay. So let's take this off. Let's go with number 2. Number 2. Whatever shape is this? A cylinder. Not so. Now how do we calculate the volume? Sorry, the total surface area. The total surface area is going to be perimeter of base times height plus twice area of base. Okay. So the perimeter of this base, the perimeter of that circle, circumference of that circle. Not so. How do you calculate circumference of the circle? It's going to be 2 pi r times height plus 2 area of the base power squared. Okay, I mean not to write the formula down. But anyway, so you got 2 pi. What's the radius of the circle? 3.5 times the height, which is 5 plus 2 pi. What's the radius? 3.5 squared. So let's put that in the calculator. is 2 pi times 3.5 times 5 plus 2 pi times 3.5 squared. 119 over 2 pi, which is 186.92. Is that correct?
Yes.
186.92 centimeters. Okay, any confusion here? Yes? One this one? No problem. Comma 9. Why you like that with us? With a decimal? You that kind of go like to follow instructions? No. Okay, I was going to give you instruction now, but no, since you're not that kind of girl, so I won't give you. People? Any issues here? Other than the decimal? Number 3. Okay. The girlfriend there, it's putting her head on it. Is you okay? Okay. Huh? You okay? Nice. People, here we have a triangular base right prism. So, how do we calculate the perimeter? It's going to be perimeter of base times height, surface area. Sorry. Surface area, the perimeter of base times height plus 2 twice area of base. Okay. So the perimeter of this is going to be 6 plus 4 plus 6, not so. 6 plus 4 plus 6 times the depth of this object, which is 5 plus twice. How do you calculate the area of a triangle? Half base times perpendicular height. So it's a half base. What's the base? 4. I don't have the perpendicular height. Not so. But I have the height of the object, which is 5. So the perpendicular height I need to work out first. So we have a triangle looking like this. So that's 6, 6, and 4 here. No? So the perpendicular height, let's call this the perpendicular height squared, is equal to hypotenuse, which is 6 squared minus, what is this length here? 2 squared. Yes? I don't know. She's asking you why did that times the height again? I don't know. I made a mistake, sorry. So we got the perpendicular height is equal to 6 squared is 36 minus 4 is 32. The root thereof. The square root of 32. Okay, thank you. That one? Wow, highlighting my mistake there. Gives us 80 plus 60 root 2. 16 root 2. Which is 102.63. Is that correct? Centimeters. Okay, any confusion here? Yeah, alright. Are you blowing like it? Alright, homework, exercise 8.2. Now some of you said I gave you a little homework yesterday, no? No? I think I must give you double. Okay, so here determine the surface area of each of the following solids. Note that all the measurements are in centimeters. Okay, so here we got the pyramids and the sphere, the conical shape there as well, the cones. Okay, here we got, what is this? A pencil. Okay, nice. I was going to say something else, but okay. Cylinder cone, eh? Yeah, nice. So that is a composite shape. It has more than one shape involved. Okay. Determine the length of the sides of the curve, right? Nice. You will be able to do that as well. Number 3, 4, and 5. Okay. So tomorrow we're going to look at more complex calculations. So we're just doing basics so far. No? This is what you should have understood in grade 10. Okay, so we did nothing new yet. Okay. So I'm going to stop the video at this point. I'll give you a chance to start your homework. Okay. Pleasure. Any other confusion of the lesson of yesterday? No.